Hi everyone. So now we know that IP addresses, more specifically IPv4 addresses, they're used to identify nodes in a computer network. The IP address is of 32 bits size, which means around 4 billion IP addresses are possible. Can we assign a unique IP address to each single device in this world? Not possible, right? Because in that case, we will run out of IP addresses very soon. So subnetting came to rescue us from this issue. Subnetting creates a network segment in which limited number of nodes communicate with each other. There's a direct communication between those nodes within some network segment. Usually it's a LAN sized area, local area network, which can be your home or your college building or your office, etc. So each node within a LAN is given some IP address which is private and unique only in that network segment. This network segment is isolated from rest of the nodes in the world. And the reason why these IP addresses are called private is because these same IP addresses can be used by some other nodes which are in some other computer network segment somewhere else in the world. So everyone is free to choose their own private IP addresses. So the devices that are present at your home, if they are using some IP addresses, those same IP addresses can be used by the devices which I am using at my home. And they are unique in that network segment only. And for the communication within a particular network segment, or I should say within a LAN, they use private IP address. Private IP address is used for the communication within a single LAN network. And we usually call it intranet instead of internet. So the devices that are communicating within LAN, they are using intranet facility. How to check if two nodes which having some IP addresses are part of same network segment or different network segment? So subnetting we have something called subnet mask, and there are two ways of doing subnetting. One is classless addressing and one is CIDR approach, classless interdomain routing. And CIDR is now used nowadays, so we'll talk about CIDR only. So along with IP address, something called subnet mask is also assigned to each node in your network segment. And subnet mask is used to get the IP address of network to which your node belongs. Yes, so there is something called network IP address. The network segment that you are using, to that whole network segment, we also assign an IP address, and that IP address is called network IP address. Just like an IP address, subnet mask is also represented by 4 octets separated by dots. In subnet mask, we can have either value of a bit as 0 or 1, right? And we have bit values equal to 1 starting from the leftmost position till whatever the position we want in contiguous manner, and rest of the bits are 0. A shorthand notation /n is used to tell how many bits are set. For example, here you can see this is a /12 subnet mask in which from the leftmost side only 12 bits are set and rest of the bits are unset. And this is our /12 subnet mask. Now, by looking at IP addresses and subnet mask, we can tell what is the IP address of network segment, or I should say IP address of network or network IP address to which a node belongs. So if network IP address of two nodes matches, then they are a part of same network segment, right? otherwise they are not, vice versa. So we just have to uh, find out what is the IP address of particular, what is the network IP address of particular node's IP address, right? So given an IP address of a node and its subnet mask, we have to find what is the network IP address. Then how to find that? So in your subnet mask, uh, in which we have some ones in the leftmost side and rest of the bits are 0. So we have two portion in your subnet mask. One portion is filled with ones and second portion is filled with zeros. So this divides uh, your IP address into two portion. One is network portion and the other is host portion. The bits in your IP address corresponding to which the value is 1 in subnet mask are part of a network portion, and rest of the bits in your IP address corresponding to which we have zeros in your subnet mask are a part of host portion. Host is nothing but node. We are calling host to the node only. If we decide to choose /12 subnet mask, then two IP address whose first 12 bits matches exactly, then they are part of same network segment, otherwise they are not. For example, if we have this /12 subnet mask in which first 12 bits are set, the rest are unset, and we have this IP address 1 and this IP address 2, in this IP address we can see that these first 12 bits of IP address 1 and these first 12 bits of IP address 2 are exactly same, which means IP address 1 and IP address 2 are of same network segment and they have same network IP address. If first 12 bits do not match between any two IP addresses which are using this /12 subnet mask, then they are not of same network segment. As long as nodes are communicating within their network segment, there is no requirement of public IP addresses. A public IP address is assigned to the router with which our network segment is connected. So in order to communicate with nodes which are in different network, a node has to use public IP address of its network segment's router. Right? So router's IP address, public IP address, is used by the node within the network segment to communicate across the network. So private IP address of that node is mapped with the public IP address of the router, which is helping that network segment to connect to the internet. So what conclusion we have arrived? By doing all these private addressing thing and creating a sub network, a local area network, doing subnetting, we saved from assigning unique public IP address to each single device. So we are not assigning public IP address to every single device, right? We are assigning IP addresses to the routers only. So in one LAN we have one or two routers, and routers are very less as compared to the end devices. So we have saved our IP addresses. IP addresses are very limited in number, so we have to use them judiciously, right? Now you might be thinking that internet consumption is increasing every day, right? So if we still run out of IPv4 addresses, which we are assigning to these routers, what will happen then? Right? What if the number of routers become larger than the total number of possible IPv4 addresses? In that case, we can switch to IPv6 addresses, in which total possible IP addresses are around 10 raised to power 14. However, the population of the entire world is around 8.1 billion, which is around 8 times 10 raised to power 9. So if we use IPv6 addresses, then even if we assign unique IP address, unique public IP address to every single device, still we will never run out of IP addresses, IPv6 addresses.